Once the third part is done, let's look at the fourth part. You are told to, by considering part 2 and 3, to show that this, by method of difference, this exists, right? So let's look at this part here. Now, first thing you need to take note is actually these two are two neighboring terms. So this is k and k plus 1. And there are difference between two terms here. So k plus 1 minus k, tangent inverse k plus 1 minus tangent k. So you could actually perform a method of difference using this expression here, okay? So just let's just use these first and we'll see how things goes about. So from this expression here, we know that actually what you could do is you just attach n, because they want from let me just show you this. This is 1 to n, this is 1 to n, right? So I'm just going to attach the sigma notation throughout here. This will be attaching k equals to 1, k plus 1 square plus 1 will be less than, if we just add this up, k plus 1 minus tangent inverse k, okay? And I'm just going to bracket this in the sigma notation, and after which I'll just put this as k equals to 1, k squared plus 1. Alright, so this is done. Now once this is done, what we're going to do is actually this middle one, what we could do is a method of difference. So if you were to write this down, I think I'll just separate it out, because it's easier to solve separately instead of putting in the inequality here. So this will be tangent inverse 2 minus tangent inverse 1 plus tangent inverse 3 minus tangent inverse 2, and tangent inverse plus tangent inverse 4 minus tangent inverse 3. Okay, so this will just go all the way to plus tangent inverse n plus 1 minus tangent inverse n plus tangent inverse n minus tangent inverse n minus 1. Okay, so once this is done, we're going to cancel this part here. Cancel it out. Cancel, 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 cancel. And once this will just give us tangent inverse n plus 1 minus tangent inverse 1. Tangent inverse 1 will be power 4, right? Yeah, but anyway, we just leave it as it is first, because we need to use the second equation here. So once this is done, we're gonna take this and combining 1 and 2. 1 and 2, we get the middle would be k plus 1 square plus 1 tangent inverse n plus 1 minus tangent inverse 1 less than n. Okay, always know what you need to find, because we have already got the two sides here, so we are quite happy with it. But what we need now is actually this side here, which looks something like that. So this is x, this is y, then is xy minus 1. So meaning to say, this would be x. This is my x, and this is my y, right? So if you look at the expression there, it's as such. Okay, it's a wrong one. Sorry. Capture one. Yeah. So we're gonna use from 2 or 3. From 3. Okay, from 3. This will just be n k plus 1 square plus 1. So you just replace this as n plus 1. X is n plus 1, and y. And this part here will be tangent inverse x minus y. So n plus 1 minus y over 1 plus n plus 1 times 1. Alright, so this is pretty okay. I think once this is done, it's pretty straightforward, right? So we're just gonna rearrange this, and this will be n, k equals to 1, and this is k plus 1 square plus 1 between tangent inverse n over n square plus 2. N. Okay, that's a good thing about proving. Yeah. So just check. There you go, this is proven. Okay, so this is how we do this question here proficiently. Any question or comments, please do let us know. Keep practicing it and I'll see you in the next question.